5 of the prelim exam of 2022. So we're looking at question 5. So we look at question 5. We see that question 5 is written as question 5. Start on a new page. Grade 12 learners conducted investigation to verify the speed of a race car using the Doppler effect. A race car driving around a race course at constant speed emits a single frequency of 200 Hz. A learner standing on the final straight records the sound using a cell phone as the car approaches him and after passing him. For this investigation, write down a dependent variable, a control variable, a suitable investigative question for this experiment. So in every paper that you write, you will get one experiment that you will have to write the dependent or independent variable. You'll have to draw a graph, whatever the case may be. So you should get used to answering questions on types of experiments that can be conducted. So the dependent variable is one that we will have to work out. So the dependent variable in our case for the question 5.1.1 is the change in the observed frequency. We'll see that what is it dependent on? As the car moves towards you and passes away, then the frequency will change. The change in the observed frequency is the dependent variable. The next question is control variable, the variable that does not change, it must stay the same. We see that constant speed emitted by the car, or the speed of the car itself. So we can say 5.1.2, the speed of the car is a constant. And then the third question is, you must write down a suitable investigative question for this experiment. So it must be a question, so it must start off with a question saying what or why. What is the relationship of the change of frequency that will be heard compared to the speed of the vehicle? So here you should say there must be a question, so it must start off with something like what. Then you must talk about here we see the change in the frequency, the dependent variable, and then compared to the speed of the vehicle. So there must be some 2 or 3 variables that you must put in the equation. Okay, the next question that we have is 5.2. When playing back the sound recorded by the cell phone in the presence of an oscilloscope, a difference of frequency of 67.15 Hz was registered. Use the information above to calculate the speed of the race car. Take the speed of sound in air as 340 meters per second. Okay, so now we're talking about the change in frequency, so we need to do a calculation. Let's see what calculation we will use for 5.2. So we know that we got FL is equal to V plus minus Vs, or V all over V minus plus minus Vs Fs. So we got one that we got FL is equal to V all over V minus Vs Fs, and we got FL is equal to V all over V plus Vs Fs. So what do we know is the one is moving towards, when the object is moving towards, and then the other one is moving away. So looking at what we have, we can say the frequency of the lesson is equal to V. We must use the speed of sound, which is 340 all over 340 minus Vs times Fs, and in our case the frequency of the source is 200 Hz. So this is when the object is moving towards the listener. And if you work out for going away from the listener, we can say FL is equal to V, which is 340 all over 340 plus Vs times your frequency of the source, which is 200. So we got those two variables that we have. And there's one more thing that we have in front of us, is that the difference between moving towards and moving away is 67.15 Hz. The difference in frequency of 67.15 Hz is registered. Alright, so we'll have to take that into account when we're doing the sum. So we can say the change in frequency is the frequency away minus the frequency towards. And if you work that out, we can say the change in frequency is minus 67,15. Then if you take your frequency away, which is 340 all over 340 plus Vs times 200, if we write it down, 340 all over 340 minus Vs, 340 plus Vs multiplied by 200 and you put it in brackets, and then you look at the frequency towards 340 all over 340 minus Vs 200. So this is the equation that we've got. So now looking at this, we have to calculate the Vs, the velocity of the source. Now how are we going to do that? What we'll have to do is we'll have to write it as a quadratic equation. So the lowest common decimal is 340 plus Vs, or multiplied by 340 minus Vs. So we multiply that throughout this equation above, and let's see what we get. So you got minus 67,15, and you multiply it by the LCD, 340 plus Vs, 340 minus Vs is equals to, then we go to the other side, 340 times 200, what gives you 68,000. 340 times 200 gives you 68,000. And then you multiply it by the LCD, and then you get 340 minus Vs, because the 340 plus Vs will cancel out. And then on the other side we'll say minus, and again we'll say 340 times 200, which will give you 68,000. And then we'll say 340 minus Vs, and then we multiply by 340 plus Vs, and you say 340 plus Vs is what we have there. Now if you multiply this out, we'll say multiply the brackets out, we get 115,600 minus x squared. Alright, then you can put it in brackets, and on the other side, if you multiply it out, you'll get big numbers, 2312000 minus 68,000 Vs, not 68,000x, it must be Vs, minus 2312000 minus 68,000 Vs. It mustn't be x, it must be Vs, right? I'm not going to touch it because this is going to affect to rewrite it will be a bit of an issue. So I'm just telling you that this must be 68,000 Vs, and this will be minus 68,000 Vs, and this will cancel out. And this x, this mustn't be x squared, it must be Vs squared. It mustn't be x squared, it must be Vs squared. Okay, we got it in brackets. So then you got, if you multiply it out again, 67,15 times 115,600, and then there we'll get 77,6254 minus 67,15 Vs squared. Now in case of you, instead of using Vs squared, I've used x squared because of the maths, but you should use Vs squared. And if you multiply the other, and you work out the other side, if you work it out, it will be 2312000 minus 231,000 will cancel out, and then you got minus 68,000x, and you got minus 68,000x, so it's twice 136,000x. That's what you have. So we see we've got a number, we got x squared, we got an x, and we got a number itself. So we can use that and put it all on one side, and this is what we've got. 6715x squared plus 136,000x minus 77,62540 is equals to 0. So when we got this, now what we can do is use the discriminant. X is equals to minus b plus minus the square root of b squared minus 4ac all over 2a. So we write it down, minus b plus minus the square root of b squared minus 4ac all over 2a. That is what we're going to do. So we've got our a, this is our b, this is our c. So we can use that, and if we substitute it, minus b will be minus 136,000 plus minus the square root of 136,000 squared minus 4 times a, which is 67,15, times c, which cannot fit in there, so I put it on the top, 77,62540 O. So that's how it's going to fit there under the square root sign, right? All over 2a. So that will be divided by 2 times 67,15. And if you put this directly into the calculator, you'll see that it works out that x is equals to 55,55. So that was quite a mission. It was a sum that you needed your maths, but that will be the answer that will work there. The other part, you get a negative answer which doesn't fit in, so we won't go into that. So 55,55 is the answer that we were looking for. All right, so take the it says use the information above to calculate the speed of the race car. So the speed of the race car will be 55,55, and then obviously we must put in the speed. Speed will be in meters per second. Don't forget the unit. Then going further, we'll see if we have to calculate 5.3. The question is the spectrum of light from most stars contains lines corresponding to helium gas. Diagram A shows the helium spectrum as observed in the laboratory. So here's it. We've got two lines, one line, and then we've got three lines. The first two lines are at 500. The next one is here before 600, etc. Diagram B shows the helium spectrum of light from a distant star. So from a distant star, we see that these lines, they're not between 500, they towards the right. They moved away from the 500 towards the right. The one that's near the 600 on the left here, it's on the right, and this one also has moved to the right. So we see that the wavelength has increased. So from this we can say, is the star moving towards or away from the Earth? We can say that it is moving away from the Earth because the wavelength increases. Away from, that's the answer. The spectrum is moving towards the longer wavelengths. Thus, the star is moving away. So that will be the way we can answer question 5. Okay, question 5 was usually, they usually ask easy questions for question 5. You can get a lot of marks. Unfortunately, in this case, 5.2 was really a mission to work out using the discriminant, and then if you have to work it out, you need to know your maths. But basically, we've got the answer. Don't forget the unit. And with that, we will conclude question 5.